All right, this video is going to talk a little bit about compound inequalities, but again, in order to do that, let's go ahead and review real quick how to solve an inequality. So I'm going to go kind of fairly quickly here, but taking a look, we've got a couple inequalities up top here. On the left, 3x minus 7 is less than 5. So the first thing I would do is add 7 to both sides. So this becomes 3x is less than 12. Then we're going to divide by 3 on both sides, and you get x is less than 4. Notice I didn't have to flip the sign because I had a positive 3 that I divided by on both sides. So again, in an inequality, if I was graphing this, open circle, no equal sign, and x is less than, right, going downwards. Now over here on the right, well, the same idea. First thing I would get rid of is that 6. I don't see variables on both sides, so I want to get my like terms together. I want to get my constants together. So this just became negative x. Again, is less than or equal to 1. And again, I need to get rid of that negative. Negative x is not a good enough answer. So I'm going to divide by negative 1, which means that I am dividing by a negative number. I'm going to flip that sign to be greater than or equal to, which makes negative 1 on the right, 1 divided by negative 1. And again, negative 1 on my number line, greater than or equal to, so solid dot, and going to the right. Now, a compound inequality has a little bit different flavor to it. Let's consider the above answers as a single compound inequality. What if we said we wanted an answer that was less than 4, just like we did up here on the left, and greater than negative 1, right? Greater than or equal to negative 1 at the same time. Less than 4 and greater than or equal to negative 1. Well, let's go down to our number line. Let's put our negative 4 on here. Go ahead and say negative 4, which makes negative 3, 2, 1. Here would be 0. Here would be positive 1, right? Again, we had a negative 1 over here, though. Oops, that wasn't negative 4, though. I better back up. Over there on the left, it was a positive 4. So I got to back up here. 3, 2, 1. This is 0. Going to negative 1. All right, now we've got that all situated. Well, to be less than 4, we need to be open circle at 4. And I'm good with anything to the left of that. Just like our graph up top shows. I want everything left of that. But at the same time, and I want to be greater than negative 1, which means I don't want to let my line go past that negative 1. I want everything left of 4. But I don't want to go past negative 1. I need to be greater than or equal to negative 1. So again, solid dot at negative 1. But I would only want to travel to the right of, right, that negative 1. So really what it's saying is in order to be less than 4 and greater than negative 1, we need to sort of be in between, right? We need to be between those two numbers. How could we write that as a single inequality statement? Well, let's use our little space that we have up top here. If I wanted to have all numbers, so I'm going to call that x, that are less than 4, well, again, I usually want to write it just like that. Low to high, right? X is less than 4. But at the same time, x needs to be greater than. Well, again, if greater than is typically to the right, well, then x being greater than should be on the right side of my inequality, right? And if I put that negative 1 over here, that's exactly how it reads. Negative 1, right, is less than x, which is also less than 4. X is greater than the negative 1, but x is less than the 4. X is between negative 1 and 4. Now, I know that left side can be a little bit confusing sometimes. So you got to remember, read from left to right. The lowest number is negative 1, which was less than or equal to my variable. My variable is to the right of. My variable is the line, right? It's all these numbers on the line. Right of my negative 1. And then at the same time, x is less than 4. We don't want to go past that 4, right? We got to stop at 4. X is between, again, negative 1 and 4. Let's take a little bit longer look at that. Compound inequalities can be any one of two different things. They can be and, like we just looked at, where x is between two numbers. 0 is less than x, but 4 is greater than x, right? X is between 0 and 4, so we get this sort of between idea. That can also be written separately with the word and. X is greater than 0, right? We're to the right of 0. and less than -4, right? Less than or equal to, sorry, +4. So we're in between these two numbers. You can also have OR equations or inequalities. A compound inequality can be an OR as well. We have two different inequalities being attached together with OR. Now, OR can't be written like the AND ones. OR can't be written as a single statement because x is less than -1 is this line. X is greater than 2 is this line on the right. And because those two lines never cross, you really can't write a single statement, right? It can't be represented with a single line, then you can't write it with a single statement. But because it's OR, if either one is true, then we're okay. Remember, for AND, they either have to both be true, so I have to be greater than 0, and less than or equal to 4, or it's not a true statement. For OR, if the first one is true, then hey, I've got a true statement. That's true, or the other one. Well, hey, I'm perfectly fine with one thing being true. Let's take a look at a couple examples here. So, how to solve a compound inequality. Over at the left, if it's an AND, notice that triple statement going on. I see my variable is in the middle statement of the 3. Well, very simply, let's solve like we always do. If I'm trying to get x by itself, let's add 8. Only this time, instead of adding 8 to both sides of my inequality, I need to add it to all 3 parts. Notice I've got a middle statement, I've got a statement on the right, and I have a different statement. There's my inequality, right? I need to separate that out. I'm going to do 3 separate statements. So again, I'm going to add 8 to all of them. -2 plus 8 is 6. Still less than or equal to, right? Kind of like an equal sign, it's still there. 3x minus 8 plus 8 just became 3x. Still less than or equal to. And 10 plus 8 is 18. I still have a compound inequality, right? I haven't lost any of the parts here. And again, my goal is get the x by itself. I'm not that worried about what's happening on the left or what's happening on the right. Those are just numbers. I'm trying to get x by itself. So my next step would be divide by 3. But remember, I've got to divide all 3 parts so that in the middle I get just x. Notice my inequality symbols are still there. It was a +3 I divided by, so I don't need to flip the signs. 6 over 3 is 2. 18 over 3 is 6. And again, because x is now all by itself in the middle, that's a perfectly good statement right there. If I picture that on a number line, again, I've got a 2, I've got a 6. They're both or equal to's. And x is greater than, right? It's between greater than the 2, but less than the 6. Over here at the right, if we're solving an OR inequality, notice we sort of have 2 separate inequalities. So you can sort of treat them that way. Let's subtract 1 from both sides on the first one, getting us a 3. Again, we'll divide by 3 there. And very simply, x is less than 1. Or, notice that carrying down. Now let's solve the other one. We're going to add 5 to both sides. 2x is greater than 12. Divide by 2. X can be greater than 6. Now we know we still have 2 separate statements, but again, remember that OR is on a number line. Typically will end up being 2 separate statements. 1 and 6. X is less than 1. Open circle going to the left. Or x can be greater than, again, open circle going to the right, of 6. Again, OR statements will typically be those 2 separate parts. Let's do a couple more examples very quickly here. Over at the left, we've got an OR. So just like we just did, let's go ahead and solve them separately. I'm going to add 5 to both parts. So again, 6x is less than 12. Divide by 6. And x is less than 2. Or, again, carry down that or. Subtract 1 from both sides. 8x will be greater than 24. Divide by 8. And x will be greater than 3. Well, let's take a look at that OR statement then. We've got 2 on our number line. We've got 3 on our number line. X is less than 2. Or X can be greater than 3. Again, just looks just like an OR graph should. 2 separate lines pointed in opposite directions. Over here at the right, let's go ahead and solve. So again, notice X is in the middle. So the first thing I'm going to do is I'm going to add 2. I want to get rid of that 2 from the middle. But because it's a triple statement, I need to add 2 to all parts. -2 plus 2. Well, now some people would say, oh, that disappeared. Well, no. -2 plus 2 is 0. That's a perfectly good number. There is still a part there. You'll never lose the inequality. It'll never just disappear. So again, -2 plus 2 is 0. Still less than. -2 plus 2 disappears. So we still have a -x. Still less than. And 1 plus 2 is 3. Now, to get x totally by itself, I need to divide by -1. So I'm going to do that in all 3 parts. Now, here's where it does get a little bit tricky. If you divide by a negative, remember those inequality symbols need to switch sides, right? They need to flip around. -x divided by -1 is just x in the middle. But again, 0 divided by -1 is 0. 3 divided by -1 would be -3. And doesn't it make sense? 0 is greater than x, which is still greater than -3, right? Isn't 0 always greater than -3? If you read that as one big long statement, 0 is greater than -3. Well, that makes sense. Now, because we flipped that all around, graphing gets a little bit tricky. So what I might want to do is kind of switch the order there. I'm going to sort of flip-flop it. I'm going to put that -3 on the left. Remember that my inequality was pointed at it, right? Remember that arrow points at the smaller number. So in order to go from least, -3, being less than, right, pointed at the -3, I'm still going to point at the -3. I'm going to put that 0 way over here on the right, which remember, alligator eats the big number, right? The line was separate next to the 0, where it's greater than. So again, the greater than part goes toward the 0. And again, x is still in the middle. What that helps me do, though, is take a look at my graph. -3 and 0. No equal signs, so open circles. And again, x is greater than the -3, but at the same time, less than the 0. I hope that helps you with compound inequalities. If you have any questions, make sure you talk to your teacher. Put in lots of practice, and have a great day.